test we have discussed, and we have discussed about homogeneity test, that is Leibniz test we have discussed, paid sample t-test, one-way ANOVA also we have discussed, even repeated measure ANOVA also we have discussed. It is not there, but that is also we have completed. And we have even seen chi-square test and Mann-Whitney U test. So in non-parametric methods, two methods we have discussed, that is chi-square test we have completed and Mann-Whitney U test, and some doubts also we have were able to clarify last day. And today's session we will be seeing about McNemar test, Wilcoxon sign rank test, Kruskal-Wallis test, and Friedman test also I will discuss. It is not there here. And after that we will be discussing about factor analysis, reliability test, that is Cronbach alpha test we will be discussing, and concepts of validity of the data. And last we will discuss something about multi-collinearity, how to do multi-collinearity also. This is what we are going to discuss. So first we are going to discuss about this Wilcoxon sign rank test. Okay, in the last day session we have seen like this. When we are using chi-square test, I said chi-square test is used when we have both. Okay, let me show the slide. This is what we discussed last day. When we have independent variable nominal data, dependent variable is also nominal data, then we are using chi-square test. Okay, and when we have independent variable as a nominal with exactly two levels, and a dependent variable is scale data, then we are going to use Mann-Whitney U test. This test we are going to use when we have independent variable nominal, like gender we have taken, for example, male and female, they are exactly two levels, they are nominal data. And we are using like GPS score, then it is a scale data. Then we are using Mann-Whitney U test. And if you can see here now when we use Wilcoxon sign rank test, same, we will be having independent variable nominal with exactly two levels, but they are not independent, like male and female in the variable, gender variable, they are independent, but here they will be dependent. And we will be having scale. Sir.
So can you please just enhance the screen?
Yeah.
Thank you, sir. Yes, sir. Yes. Yes, sir. Thank you.
Yeah. So this is what we are discussing. When we discussed last day about Mann-Whitney U test, the independent variable is nominal, but the levels are independent. And we said that number of variables are 1, type of data is scale data or ordinal data. We are using Mann-Whitney U test. Now, when the variable levels are not independent, but they are dependent, then we will be using Wilcoxon sign rank test. So this is what we are going to discuss. And Wilcoxon sign rank test is similar to that of paid t-test. Last day we did paid t-test. That is for parametric test. In place of parametric test, if you want to use a non-parametric test, then we must use Wilcoxon sign rank test. Then we must use this Wilcoxon sign rank test. Last day I was saying, two independent sample t-test, it is parametric. In its place of parametric, when you want to use non-parametric, we are going to use Mann-Whitney U test. The similar way, in paid t-test we are using for parametric. In case you want to use non-parametric, then you must use Wilcoxon sign rank test. Wilcoxon sign rank test. So let us see how to do this Wilcoxon sign rank test. Participants can take a screenshot of this one and you can save in your system. You can go through a number of times so that you'll understand actually the concept. So Wilcoxon sign rank test. This data file is already shared. Wilcoxon sign rank test. Yeah, in this case, you will be seeing there are 3 variables are there. Employee ID means employee is nominal data. Pre-performance and post-performance of employees are given. pre-performance, post-performance. These two are scale data. And we want to test, is there any association between pre-performance and post-performance? If you see here, these all are employee IDs. They are totally 22 employees are there in the organization. And before training, their performance is given here. This is scale data. And after the training, again performance is been given here. Now I want to test, is there any significant difference between pre-performance and post-performance? So here we are taking assumption that this performance which you are saying is a scale data is not normally distributed. In case if you check it and if it is normal distributed, then you must use a paid t-test only. If the scale data, I repeat, if the scale data is normally distributed, then we must use paid t-test. But why I'm using Wilcoxon sign rank test? Because I'm keeping an assumption that these two scale data are not normally distributed. If this is not normally distributed, then only we are going to do non-parametric method. So I am using now this non-parametric method, which is called as Wilcoxon sign rank test. Any doubt anyone have, can ask it. Hello? Hello?
No, sir, carry on.
Yeah. So now I'm starting the analysis, how to do this Wilcoxon sign rank test. Okay. We are going to click on analyze. In analyze, non-parametric test. In non-parametric test, legacy dialogues. In legacy dialog, we must select two related samples. Two related samples, because pre and post, there are two which are related, which are dependent. Right? Click on this two related sample. Now we'll be getting this screen which is say two related sample test. Select pre-test and post-test. It looks similar like paid t-test. When you did last day, paid t-test, it is similar. And you can see here, they have given different options are being given. We are selecting Wilcoxon. It is by default. By default, we have Wilcoxon. So it is selected. Now I am clicking OK. I have not did any changes. I have selected pre-test variable 1, post-test as variable 2. And by default, Wilcoxon is already selected. I am clicking OK. And before click OK, I want to say the null hypothesis once again. A null hypothesis is there is no significant difference between pre-performance and post-performance. So there's a null hypothesis. Let me click OK. Now once I click OK, you can see here the asymptotic significant value is 0.001. Already last day also we have discussed, if the significant value is less than 0.05, we are going to reject the null hypothesis. Now in this case, the null hypothesis is rejected. What is the null hypothesis? There is no significant difference between pre-performance and post-performance. So that's where rejecting means there is a difference between pre-performance data and post-performance data because the significant value is 0.001. This is how we are going to do Wilcoxon sign rank test. To confirm this, we must know the means of pre-performance data and post-performance data. Let us see what is the means. Analyze, descriptives. In that again, descriptives. Select pre-performance, post-performance. Click OK. Now you can see that pre-performance, the mean is 59.32. Whereas post-performance, it has increased 71.32. Means the performance of the employees have increased. It was before training, it was 59.32, and after the training, the post performance of the training is 71.32. So clearly we can understand there is a significant difference between pre-performance and post-performance. So this is how we are going to do Wilcoxon sign rank test. Any doubt how you can ask at this moment?
So how did you do this mean? Analyze?
Yeah, simple. It's a basic one. Analyze, descriptives. In descriptives, again select the descriptives.
Okay.
After clicking this, select the two variables, pre-performance and post-performance. And click OK. Once I click OK, we are going to get a descriptive statistics, pre-performance mean and post-performance mean. This is to confirm, is there any difference or not? To check that one, I did this descriptive statistics.
So in previous and all, we used to put both the variables like ID and the pre-performance, but in this one, we are just moving only the performance level, no? The ID stays where it is.
Correct. Correct. Because this is called as a paid dependent variables. For the same employee ID, we are taking twice.
Okay.
In earlier one, they are different groups. Male is separate group, female is separate group. That's why we want to know the difference between male and female. That's why we have included that gender.
Okay.
But here what happened, it is the same employee before training performance is given here. For example, you see this employee ID 1. His marks, he got 77 marks. After the training, 89 marks. So I don't want to see again between the IDs. I'm not interested to see what is the difference between each employee ID. I'm only interested between pre-performance and post-performance. So I'm including only these two variables.
Okay, sir.
Okay.
Okay. Thank you, sir.
Yeah.
Sir, one more doubt, sir.
Yeah, please.
Sir, when we are using this mean, it is showing the significant difference. And then what is the use of significance that Wilcoxon will be used for?
I'm not able to hear your voice, sir. It is getting lagged. Your voice is getting lagged.
When we did the mean, we are able to find out the significant. So when we check the mean,
are you asking that already you have checked the mean and why you want doing this significance test? Is it correct? Hello? See, when we did mean, we are able to see, for example, in this case itself, the mean is 59.32 for pre-performance, post-performance 71.32. Here it is clearly that we can say that there is a difference. For example, if the pre-performance is 70.32 and post-performance 71.32, can you say there is a difference or not? We need to prove with the statistical test only. That's why we are doing significant test, in order to confirm that.
Sir,
Yeah, just to confirm it
doubt.
with a statistical test, we are doing that. Yeah, please.
Sir, in the output file, there's this Z value. What does that indicate?
Which
Under
one?
test statistic and before descriptive, sir.
Okay.
Yeah, under test statistics, there's this Z value minus 3.2.
This is book value, madam. Z value. It must be more than 1.96. We'll check in book values, right?
Okay, sir. Okay, all right. Thank you.
There's a Z value, which is a negative. Negative means post is greater than pre. That's why we are getting negative.
Okay, sir.
Now, when we are doing earlier without the software, people used to look at the table at the end of the book, right? So just for citation purpose, they have again kept a Z value. But now software is developed in such a way that we are directly getting the significant value only.
Okay, sir.
Yeah. Any more doubts? Okay, I'm going for the next topic. Now we will discuss about Kruskal-Wallis test. Okay, now we have completed man-white U test, Wilcoxon sign rank test. Now we are discussing about Kruskal-Wallis test. Now Kruskal-Wallis test is similar to that of one-way ANOVA. One-way ANOVA. Okay, when we use one-way ANOVA, if they are more than 2 levels, we are using one-way ANOVA. Last day we discussed, if they are exactly 2 levels, we use a t-test. If it is more than 2 levels, then we use one-way ANOVA. In the same way, if you have exactly 2 levels, we use man-white U test. And if it is more than 2 levels, then we are going to use Kruskal-Wallis test. In simple sentence, if you want to say, in parametric test, when we use one-way ANOVA, in non-parametric test, we will be using Kruskal-Wallis test. Kruskal-Wallis test. Is it okay? Same like one-way ANOVA, but in non-parametric method, we are using Kruskal-Wallis test. So here, in one-way ANOVA, we must have an assumption that the scale data should be ND. ND means normal distributed. But we don't have the same condition in Kruskal-Wallis. In Kruskal-Wallis, data can be dependent variable can be scale data or ordinal data. And the scale data, we don't have a condition that it must be normally distributed. If the data is not normally distributed also, we can use this Kruskal-Wallis test. Is it okay? Right. Now, okay, we don't have any example here. We'll take the same grades example last day which we have used. Same example which I have used, I am doing for Kruskal-Wallis test. We have discussed between specialization. Is there any difference between specialization towards GPS score? Right? Only condition we kept in the last case is that this GPS score is scale data which is normally distributed. Now we are assuming that the GPS score is not normally distributed. Okay. Now also we have seen whether it is normally distributed or not. How we have checked that one? Analyze, descriptives. In this explore. In explore we have taken GPS score. And in the plots we have selected this normality plot. And clicked OK, and we have clicked OK. Now here, okay, this value, significant value, if it is less than 0.05, we assume that data is not normally distributed. So the GPS score data is not normally distributed. So with these conditions, now I am doing Kruskal-Wallis test. Is it okay? So when you do test of normality, last day only we discussed this one. Kolmogorov-Smirnov should be taken if the sample size is 30 and more than 30. If it is less than 30, you must use Shapiro-Wilks test. So now I want to do Kruskal-Wallis test to check is there any significant difference between specialization and GPS score. You can see specialization is a nominal data and GPS score is a scale data. Same thing which I shown in the PPT also. The independent variable is a normal data more than 2 levels because we have marketing, finance and HR. And dependent variable is only one, which is a scale data. So I'm using this Kruskal-Wallis test. Can I go ahead?
Yes, sir.
Yeah.
Yes.
So I'm starting the analysis.
Yes.
With the null hypothesis, there is no significant difference between specializations. There are 3 types of specializations: marketing, finance, and HR. To GPS score. So I'm starting the analyze. Click analyze non-parametric test. In non-parametric test, legacy dialog. In this, K independent sample must be selected. K independent sample. Okay, analyze non-parametric test, legacy dialog. In legacy dialog, K independent sample. Click on this K independent sample. Now here the testing variable is GPS score. Grouping variable is specialization. Okay, after selecting specialization, you need to define the range because it is more than 2. So we need to specify here minimum is 1, maximum is 3. Because we have 1, 2, 3. If it is like 5 we have, we must select 1, 2, 3, 4, 5. So we must say minimum 1, maximum 5. Click continue and click OK. That's it. And you can observe here, by default, Kruskal-Wallis is selected. The check button, this Kruskal-Wallis is selected. Click OK. Now that's it. You can see the asymptotic significance is 0.041. It means there is a difference between marketing, finance, and HR. Marketing, you can see the mean score is 42.29, finance 60.08, HR 55.35. So the null hypothesis, we already stated, there is no significant difference between specialization towards GPS score. Now, if the significant value is less than 0.05, we are rejecting the null hypothesis. So we are rejected null hypothesis and concluded that there is a difference between specialization towards GPS score. So finance people are performing good, followed by HR people, then marketing people. So this is called as Kruskal-Wallis test.
Excuse me, sir.
Yeah, please.
Can you just repeat the steps, sir? How did you select that from analyze? Yeah.
The process I'm saying. Okay. Analyze, non-parametric test, legacy dialogue. In this K independent sample.
Okay, thank you, sir. Thank you.
In this, we have selected testing variable as GPS score, grouping as specialization. After selecting it, define the range from 1 to 3, click continue and click OK. Then we are going to get the output. So already we have stated the null hypothesis. Now must observe the significant value and comment on the value. If this value is less than 0.05, then we say we are rejecting the null hypothesis. And we can support with this mean values, mean rank values. So this is all about Kruskal-Wallis test. Any doubt anyone have can ask at this moment.
Sorry to interrupt, sir.
Please say.
Attention participants, the attendance link is being shared in the chat box. Please fill the form. Thank you, sir.
Yeah. So if anyone have a doubt, you can ask at this moment. Else I'll go to the next topic. Yeah, I'm going ahead. Now we will discuss about the Friedman test. Just a moment. Friedman test is similar to that of repeated measure ANOVA. Last day we did repeated measure ANOVA. Repeated ANOVA paid t-test will use exactly 2 levels which are dependent. Paid t-test. If it is more than 2 levels, we are going to use repeated measure ANOVA. Okay, so repeated measure ANOVA is a parametric test. In place of a parametric test, if you want to use non-parametric test, then we must use Friedman test. Similar, all the features will be similar only. You can see they are independent variable, both are nominal, levels are more than 2, both are dependent only nature, and when come for dependent variable, number is 1. Here it is scale data and normally distributed, but here it is only scale data, means we don't have to see the condition of normality here. And even the data is original data also we can use. And this is Friedman test you can use. If in case if the dependent variable is not scale data or ordinal data, if it is nominal data, what test must be used? If the dependent variable is nominal data, what test must be used?
Repeated measure ANOVA.
No, madam. Say in Friedman repeated measure ANOVA, it is for parametric test. It is for parametric test.
Chi-square, sir?
Yeah, chi-square can be used. Chi-square. But chi-square, it should be independent. We will discuss the advanced one only. Chi-square, the independent variable must be independent. Okay. But here we have dependent. Okay, we'll discuss as we go on. So Friedman test, independent variable, which is nominal, which is dependent. Dependent variable is scale data, ordinal data. We are going to use Friedman test. So I already said repeated measure ANOVA is for parametric. If you want to use non-parametric method, then we are going to use Friedman test. Actually, this test we don't actually use it because after doing 200 PhDs, never we have used that. I think 1 or 2 cases, maybe maximum we have used. Generally, 90% people use t-test, 2 sample independent t-test one-way ANOVA, Man-Whitney U-test, Kruskal-Wallis test, chi-square test. Only these tests, 90% cases, these are the tests which we are using. That's why many people may not be familiar with repeated measure ANOVA. In medical trials, where we are doing for number of times, different months of treatment, then we are using repeated measure ANOVA we are using. Paid t-test, repeated measure ANOVA, and two-way ANOVA, those things we are using. For medical people, that is very important for them. For social science people, in non-parametric, Man-Whitney U-test, Kruskal-Wallis test, and chi-square test is very important tests. So let us focus on Friedman test. So Friedman test, independent variable will be more than 2 levels, and dependent variable is scale data. I don't know where we have Friedman tests.
Sir, can you please repeat the statement?
Which statement? Just now what I said?
Just now what you said. Unfortunately, my network was gone. Sorry.
Like you said, independent variable will be more than 2 levels. Means
just a moment. Generally, in social science, what we are using, we are mostly using for, in parametric, we are using t-test, ANOVA, and paid t-test. These are mostly used tests. We generally are not using this repeated measure ANOVA in social science, I'm saying. And when you come for non-parametric method, Man-Whitney U-test we are using. We are using Kruskal-Wallis test we are using, and chi-square. These are the 3 important tests which we are using. But when you come from medical field, medical people, mostly they are using t-tests, paid t-test, one-way ANOVA, repeated measure ANOVA, and they are using that two-way ANOVA they are also using. And mostly in these cases, they are not actually using this test. They may use chi-square, very rarely they use, all medical people, because they mostly depend on parametric test only. Is it okay? So let us do this Friedman test. Now in this Friedman test, you can see the data. We have 10 experts are there. They need to give rating for 4 brands of teas or any other thing. 4 brands they need to give. So each expert is giving his opinion regarding each brand. Brand 1, brand 2, brand 3, and brand 4. So the null hypothesis is there is no significant difference between the 4 brands. There is no significant difference between the 4 brands. So we want to check whether there is any difference between brand 1, 2, 3, and 4. Multiple brands are there when you want to compare. If exactly you want to compare between brand and brand 2, brand 1 and brand 2, what you must use? Wilcoxon sign rank test you must use. If it is more than 2 levels, then we are going to use Friedman test. Same thing. If there are exactly 2 levels, like you want to compare only between brand 1 and brand 2, then use Wilcoxon sign rank test. But if you are doing analysis to compare between more than 2 levels, then we are using Friedman test. Is it okay? So let us start the analysis. Analyze non-parametric tests. In non-parametric test, legacy dialog. In this legacy dialog, K related samples. K related samples. So click on this K related samples. Here, select all the 4 brands. And by default, you can see Friedman test is already selected. Click OK. Now, see this asymptotic significance. It is 0.021. If it is less than 0.05, we are going to reject the null hypothesis. Null hypothesis, there is no significant difference between. There is no significant difference between the brands. So it is rejected in the sense there is a difference between the brands. If you see the brands, if you see brand 1 is 1.75, brand 2 3, brand 3 2.25, and brand 4 it is 3. So 2 and 4 is performing very good compared to 1 and 3rd brand. So there is a difference between brands. So in non-parametric method, we are using fragment tests. In parametric, you must choose a repeated measure ANOVA. Is it okay? Anyone have a doubt? They can ask.
Sir, like in repeated measure ANOVA, we had two groups. So say A, male, female, B, group B, male, female. In a fragment test also, if we want to insert the sub-levels in the group, how do we do it?
That is 2-level ANOVA because you have gender, you have, right?
Yes, sir.
Yeah, you have gender in that. That is 2 level. This is all one level only because only one dependent variable, one independent variable only.
Okay, sir.
Okay. If you have the third variable, then automatically it is called two-way ANOVA. Okay. Levels are increasing there. Here we are only discussing about only one way.
Sir, with only this analysis, we have confirmed that the null hypothesis is rejected. Can we even infer that brand 2 and brand 4 are performing on par?
Yes. That's what we have in the summary, right? Brand 3, brand 2 and brand 4 is having good performance.
Okay, no further analysis is needed to that.
What is your objective? If you say the objective, I'll say what is, because we have so many statistical methods are there for us.
Like we went with which is the best performer if you want to check with an expert.
See, this is the opinion of the experts. This is the 10 people are there in your data. If you see this 10 experts here, there are 10 people are there. They have given, like, you are a judge and 4 people are standing in front of you. 10 people are given rating. So they are preferring brand 2 and brand 4 as the best one.
Okay, sir. Thank you, sir.
Okay, it's only preference of the experts.
Yeah. Okay, thank you.
How much first expert, how they have given rating, second expert, how they are given rating. So 10 experts are given different rating for the 4 brands. And we are comparing and saying that brand 2 and brand 4 is getting good performance. You want to see, for example, you want to compare between brand 2 and brand 4, then let us conduct Wilcoxon and see which is the one. So let me do Wilcoxon for this non-parametric in legacy 2 related sample. In this, I want to select brand 2 and brand 4, Wilcoxon I am doing, select OK. Now you can see perfectly that is accepted because asymptotic significant is 1 and you see there is no difference between brand 1, brand 2 and brand 4.
Okay, sir.
Right? Because exclusively you want to see between 2 brands, see the Z value, it is 0. 0 means there is no difference at all and you can do that eyeball test. Exactly, they are similar. There's nothing difference. Here 5, 5, 5, 5, everything is same.
Yes,
Okay,
sir.
excuse me,
Yes, sir. Thank you, sir.
Sir, here in this case, dependent variable is expert that column, sir?
See, a dependent variable expert, but our objective is to see is there any difference between the brands.
So they are the
comparing
independent
that
variables.
I'm not comparing that to which expert has given how much rating. That's not my objective.
Okay.
My objective is to see that among brand 1, 2, 3, and 4, is there any difference or not?
Okay, sir.
Sir,
Thank you.
sir, can I ask you a question?
Right. See, in statistics, everything goes with the objective. If you say your objective, I'll say what test can be used.
Sir, 1 minute. Sir, if the objective is like whether gender has any influence on the brands, like brand 1, 2, and 3, and 4, then which test you must conduct?
Gender is a dichotomous one, right? Yes or no? You have only 2 levels,
yes,
right?
Sir.
And we have here more than 4 brands are there.
Yes.
Now you want to see is there any difference between brands towards
Gender.
Between brands, more than two exactly 2 levels and more than 2 levels.
Okay.
You want to see whether they have any difference between brands. Can do
Yes,
this
sir.
test. We don't have gender here. We will go for 2-level ANOVA then.
2-level ANOVA.
ANOVA. Because there's a gender one factor is coming and you must see their experts.
Okay.
Yeah, or else you must convert into brand and this format must be changed actually. But we can do that.
Sir, if I am giving more than 2, that is gender male, female, and also transgender, then also I can perform 2-way ANOVA.
Should be, sir, because there more than 2 levels we are saying that's okay. ANOVA can be used. We have more than 2 levels.
Okay, sir. Okay, thank you.
Format should be changed, sir. This format is for dependent variables only because this is all dependent only we are talking about. When you say male and female, they are independent.
Yes, sir.
Yeah. Can you discuss that further, sir? Once you see.
Okay. Okay, sir. Okay, thank you.
Right, sir. Now, so we have discussed about Man-White-New test, Wilcoxon sign rank test, Kruskal-Wallis test, Friedman test, chi-square test. The last test we are discussing is Mack-Niemer test, sir. But only difference here is Mack-Niemer works with only exactly 2 levels, not more than 2 levels, and dependent variable is nominal. You can clearly observe that in independent variable, if the independent variable is independent, chi-square test is used. But if they are dependent, then only we will be using Mack-Niemer test. Mack-Niemer is a very special condition, sir. Generally in research, we never use this test actually. It's a very special.
Just say this again. When do we use Mack-Niemer?
Mack-Niemer generally we don't use, madam. But Mack-Niemer, see the conditions. Independent variable is nominal. Number of levels are only 2, like t-test, only 2 levels. And they are dependent. When you come for dependent variable, it is only 1 level, 1 variable, and which is nominal. In case if it's not nominal, it is scale, then you are going to automatically use what? Wilcoxon sign rank test. You can see these 2, same they are. Wilcoxon sign rank test, just a minute, I'll maximize and show you. Wilcoxon sign rank tests and Mack-Niemer both are same. Only is a dependent variable. Here it is scale data, it is nominal data. Everything is same. Like if you see Wilcoxon sign rank test and Mack-Niemer. This is nominal and this is nominal. Levels are 2 and 2. Dependent and dependent. Here it is scale data, it is nominal data. So if it is scale or nominal, scale or ordinal, you must use Wilcoxon sign rank test. If it is nominal, you must use Mack-Niemer test. Okay. So let us see Mack-Niemer test if the dependent variable is nominal. Yeah. Here you can see without training, we are seeing whether target is reached or not reached. If the target is reached, yes, 1 number is given. If target is not reached, 0 is given. In the same way, with the training, target not reached, target reached. It is nominal data. Both data, as you can see, nominal data. And the distribution I'll show you. For each respondent, how many respondents we have here? 50 people are there. 50 employees, marketing employees are there, sales people are there. So we have given them without training, how many people have reached the target. Right? And with the training, how they have reached the target. So you want to see, is there any significant difference between target reached with the training, without training? With the training and without training. 50 sales employees we have. These are data of 50 related to 50 sales employees. And without training, we have checked whether they have reached the target or not. See the first employee, with the training, without training has reached. These are all people till 20. But from 21, without training, they have not reached the target. With the training, they have reached the target. Till 35. and we have a combination again here. Target reached, target not reached. There are some people after giving training, they stopped reaching the target. This is a very odd case, right? So we want to check whether training is effective or not in reaching the target. Is it fine?
Yes, sir.
Yeah, important thing here is we are trying to see that without training, how many people reach the target. With the training, how many people reached. Both are nominal data because it's a dichotomous one. Yes or no type of questions. 1 means target reached, 0 means target not reached. Both are nominal data. In this case, we must use Mac-Niemer tests. It is not a scale data. It is not an ordinal data. It is a nominal data. Not a scale data, not a ordinal data. It is a nominal data. Target reached, target not reached. So let us do the analysis. Analyze non-parametric tests, legacy dialog, 2 related samples because they are dependent. Okay. Now, since it is a nominal data, you must take target reached with the training, without training, and select Mac-Niemer in place of Wilcoxon. In case of Wilcoxon, select Mac-Niemer. That's it. If it is scale data, ordinal data, we are going to use Wilcoxon. I already said. Since it's a nominal data, we must use Mac-Niemer test. And click OK. See the significant value. 0.041, which is less than 0.05. So we are rejecting the null hypothesis and concluding that there is a difference between target reached with the training and without training. And you can see here clearly,
sir, can I ask,
target not reached, target reached 10 members. And here target reached 20 members. With the training, people target reached is more. 20 members have reached. With the training, more number of people have reached the target.
So can I ask a question?
Yeah.
Yeah. Sir, that means this kind of test, that is the Mac-Niemer test, is only limited and to those kind of paper who are only finding the effectiveness of the training, whether they have reached or not.
Correct.
No, the scope is limited to this only.
Nominal data.
The scope is limited to only why.
That's what. That's what.
Only nominal data, no?
Yeah, I already said this test generally we don't use. After 90% people don't use this one.
I want, yes, that's why I want to just know that the scope of this kind of paper, like this kind of study, is only limited to check whether they have reached the target or not.
Correct.
Okay.
Correct.
Thank you, sir.
Right. And this is the end of the non-parametric.
So yeah. 1 minute. I need some clarification here. It's look like a type 1 and type 2 kind of errors, no, sir? So your table without training and with training.
Okay. This is not type 1, type 2. Not talking hypothesis. Already we said that we are going with only type 1 error, where we are talking about alpha value.
Okay.
We are not talking about type 2 errors.
But you are giving some confusion here, sir. These 2 columns with training.
Yeah.
Please, can you explain once again, sir, please?
You can do cross table and check, sir, if you want. If you have any doubt, you can go to cross table. Training, without training. You can go to cells and have that button. Continue. It's only digging the data, sir. You can just see it. How many people without training. This is actually a confusion matrix type of thing. Confusion matrix we call in machine learning, confusion matrix, the same type of thing. You can diagnose and see that. See, without training, target reached. With the training, target reached. These people are more. Okay. Without training and with the training, very less people are reached. Means there is a difference between without training and with the training in reaching the target. Okay.
Yes, thank you very much, sir. Thank you.
Now, this is all about non-parametric methods till now, what we have discussed. Right? Any doubt you have, you can ask.
Sir, in Friedman test,
Friedman, okay.
yeah, it says, you said it is almost similar, Friedman test and McNemar, but here it says in Friedman test more than two independent variables, right? But the nature is dependent. How is it, sir? It's a little confusing.
You are talking about difference between Friedman test and which test?
The McNemar test.
McNemar? McNemar nothing to do, madam. McNemar, Friedman, nothing to do, because McNemar is nominal data, exactly two levels.
Okay.
And Friedman test is a scale data.
Scale data.
Scale or ordinal data.
Okay.
Right, and here because I'm using this version 25 in SPSS, and I think after 21 they brought a new sort of application for non-parametric. Just I want to show you same thing what we did is applicable. I'm showing you extra feature. If you permit me, is it okay?
Yes, sir.
Yes, sir. Please.
I'll show the feature which is brought after version 21 in SPSS. Same thing, non-parametric, what you are doing, the same thing we are doing here, but only thing is it's more easy to use. That is a non-parametric test you must do. For example, I'm doing Wilcoxon sign rank test. I'll just show you once again. I want to do this. Okay. I want to do man-Whitney U test. For example, I'm saying how to do in a very easy way. Man-Whitney U test where we have nominal data, two levels, and scale data. So what I do is I will select that example only, man-Whitney U test. Okay. Sales group and sales. So I want to check whether there is any difference between performance of sales group 1 and sales group 2. This example which we have used yesterday. Okay, so how to do in a very simple form using SPSS after 21 version is non-parametric test. Here we are going to select whether it is a dependent or independent only. Just select this one. Instead of going to legacy dialog and selecting the test, we only select here this place, independent. Man-Whitney U test means independent. Select independent sample, and here see the system automatically compare distribution across the group. So we are not going to do all the test. System will select automatically what test is required. So you don't need to bother whether it is a nominal data, whether it is ordinal data, scale data, nothing to get worried. System is going to do automatically the test. Is it okay? Yeah, in the fields you only select the grouping variable is sales, and you can see what group you must select here. You must not use scale data. You can use nominal data and you can use ordinal data. So group is a nominal data I'm selecting here. And in the test variable sales I'm using. Sales can be either ordinal or scale data. That's it. Here nowhere I'm saying what test to use, right? System automatically will select the appropriate test and displays for us. That's it. So system now has selected which test, independent sample man-Whitney U test. I think, have you noticed this one? System automatically selected after 21 version in SPSS, they have upgraded. And there is no need for the researcher even to think what test to use. Day by day, due to this artificial intelligence and robotic systems, the softwares are becoming more compatible for user. So you don't need even to think what test to use. And even null hypothesis also it has stated. We don't need to make the statement also. There is no significant difference between sales group towards sales. It has made a new statement. The distribution of sales is the same across categories of sales group. And it has shown the significant value also. See the significant value 0.000, which is less than 0.05. So what we must do? Reject it. So see the decision also it has made, reject the null hypothesis. Are you able to understand what I'm saying?
Sir, can you please repeat the path for this?
Same, madam. You must go to analyze, non-parametric test. In all the cases I shown you legacy dialog, right? Now no need to go to legacy dialog. You can directly go to independent sample. Now you only decide whether it is independent sample or related sample. That's only the thing you want to do.
Okay, sir. Thank you.
So select independent sample. And after selecting independent sample, you need to select which is a grouping variable. Sales group is a grouping variable. Sales is a testing variable. And system, clearly you can see what type of data should be brought in this box. Here also you can see what type of measurement type should be brought in this. Only sales group, only nominal data or ordinal data should be entered here. And here what you are entering sales, only ordinal or scale data should be entered. And I'm not going to select any sort of test. Because here we haven't selected a button, radio button saying that automatically compare distribution across the groups. Means system will decide what type of data you have selected and system will do the test and give the output. Run. And when I say run, it has made null hypothesis statement, it has prepared. It has said what test it has used, significant value it has said, and even decision also it has displayed. Null hypothesis is the distribution of sales is the same across categories of sales group. Man-Whitney U-test, independent sample Man-Whitney U-test. Significant value is 0.00, which is less than 0.05. So rejected the null hypothesis. So easy it is. And if you double click this one, further it is going to get elaborated. This is called model viewer. You can clearly see here what is the mean of sales group 1. The mean of sales group is 14.3. Sales group 2 is 5.22, which is very less. It is very high here. So it is done. And please spend some time to check all the features it is having. Lot of features are there in this. Lot of features are there. You can go on selecting different type of features. Is it okay?
Sir,
it makes more easy to interpret the data.
Sir, after this, the hypothesis test summary we have gotten, how we can elaborate this?
Correct. You want to go into details, you can click this button.
Okay.
And you can enter into the details and do all type of diagnosis. Spend time on this and do with the new feature, which is having in SPSS after 21 version. Before that, I don't know if it is available or not.
Okay, sir.
I'm using at present 25th version. I have 26th version also.
Okay, sir. Sir, whether we can done other tests also using this non-parametric?
Everything. If you just select the appropriate, for example, Kruskal-Wallis test you want to do.
Okay.
You just need to go to here. You select the data first.
Okay.
We have Kruskal-Wallis test. Kruskal-Wallis means we have taken grades, I guess. And I want to check between specializations towards GPS score, right?
Yes, sir.
So just here, analyze, non-parametric, independent sample.
Okay.
Automatically comparison will be done. Go to the fields, select specialization, which is a group variable. Select the GPS score, which is a testing field, and click run. I'm not selecting anywhere Kruskal-Wallis test or whatever test it is.
Yeah.
Just simply I'm saying run. Now you can see it says null hypothesis by itself. The distribution of GPS score is same across categories of specialization. Test you can see independent sample Kruskal-Wallis test.
Okay, sir. Okay.
Significant value it has given, and even decision also it has kept. If it is not rejected, it will show in this blue color only.
Okay, sir. Okay.
If it's selected, it is rejected. It shows a decision is rejected with that yellow color. And if you double click on that, now this is the output. You can go on digging the data further. You can go on. You can see there are so many options are there. There will be so many options here.
Okay,
So many options we have. Tier wise, you can compare between finance, how many people. See, finance is very high. Marketing people is low in this way. It shows a difference also. Even further also it has diagnosed. Between marketing and finance, there is a difference. Between marketing and HR, there is no difference. Can you see it? Between HR and finance, there is no difference. But there is a difference between marketing and finance.
Okay, sir. Thank you so much.
Is it okay?
Yes, sir. Yes, sure. Thank you.
So SPSS has a lot of versions. That's why in academic world, people mostly use SPSS. More than programming language, like Python or other languages. Is it okay? So any doubts, participants, if you have any doubt, please, you can ask at this moment, because we are closing this topic called as parametric and non-parametric.
So this is about man-Whitney test. Morning I was just practicing. In that analyzing, in the test variable list and grouping variable list.
Okay.
So I didn't know which one to put in grouping variable and which one to put the test variable.
Madam, what is the objective? To compare between gender towards marks, right?
No. Sales group 1 and sales group 2 comparing with sales performance.
You want to compare between, madam. You want to compare between groups towards what? Sales, right?
Performance, yes.
Performance. So will performance depend on the group, or group will depend on performance?
Group will depend on the performance.
No, madam. Performance will depend on the group.
Performance will depend. Okay.
Performance will depend on the group. So performance is madam. Performance is the dependent variable. Independent variable is a group.
Group, yes.
Right. Is it clear now?
Yes, sir.
Now in a group, you have nominal data, because group 1, group 2.
Correct.
And the performance is a scale data, because it's like continuous data.
Yes, scale data, correct, sir.
Now understood, no, that what is testing variable is performance. What is grouping variable is group.
So both the, okay, fine. Yes, sir. Understand now, sir. Thank you, sir.
Yeah, man. It's only, that's what, man. Research is all about discussion. You think on that, you'll understand more. It explains a lot of things about that itself. Data explains so many things about itself when you start thinking about the data.
Okay, sir. And like whenever we do Excel, I can just do this test in one Excel, or like in the Excel there will be sheets like 1, 2, 3 sheets.
No, madam, you are going to import into SPSS, and we are doing in SPSS.
Okay, sir. Okay. Thank you, sir.
That's what, because last day when yesterday I started my discussion with showing you that data, and I explained you clearly what is the data type and what is measurement type, because all the confusion is only with measurement type only.
Yes, sir.
And in the measurement type, you need to decide which is a dependent and which is independent. Always a independent will be nominal data only. Dependent will have so many other type of data, where you have scale data, normal distributed, scale data without normal distribution. And I have so many other tests which have removed it, because you will be getting confused. So clearly I have segregated and shown you in a very clear table form.
Yes, sir.
And even I segregated levels also, exactly 2 levels, more than 2 levels, what type of is a nature, dependent or independent, and a type also I've shown you, like whether it is scale or what type, and even method also I've shown.
Right? Thank you, sir.
Yeah, it helps you a lot, madam. Only thing is, first time if you're saying it is somewhat like confusion, but go on practicing, definitely this will be very useful table.
Sure, sir. Thank you.
Is it okay? Can I go for the next topic called as factor analysis?
Sir, before that, one other doubt.
Yeah, please ask.
Sir, we had given, sir, you told how to do automatically, run automatically. In that,
Yeah.
whether we can select multiple variables in those sales groups and all.
See, it all depends on your objective. So if you see an
Okay,
example,
okay, sir. If,
then automatically I can show you, because if I go on explaining, you'll get confused there.
okay.
If you see an example, like I'm taking some examples which I already shared with you. So if you see an example, definitely I'll run and I'll show you.
For example, if comparing the brands, like we told, brand 1, brand 2, and brand 3 performance.
Brands, okay, just let me do brands. It is comes under fragment test, right?
Fragment test, yeah.
Yeah, let me take fragment test. So you want to say about fragment test, brand 1, brand 2, brand 3. Now let us do that. And these are dependent variables, right?
Yes,
because
sir.
related
Yes, sir.
sample.
Yes,
yeah,
sir.
related samples.
Yeah.
So let us go to analyze non-parametric test. Now we must not go to independent, we must go to related.
Related, okay. Oh, that there will be difference.
There is a difference. Dependent and independent, there is a difference.
Okay, sir.
Like just now, madam asked about groups, sales groups. Sales groups are independent.
Okay, yes, sir.
These brands are dependent. In field, see in independent, we don't have segregating variable.
Yes,
Only
sir.
testing field is there.
Okay.
Select all the 4. Okay. And click run. I'm not selecting what test to do. Just
Yes, sir.
simply click run.
Yes.
Now you can see here.
Yeah.
What test it has used? Fragment two-way analysis of variance by ranks.
Okay, sir.
The distribution of brand 1, brand 2, brand 3, and brand 4 are same. This is the null hypothesis,
Okay.
which got rejected.
Rejected.
We go to the details. You can see for each brand, there is a mean values given here.
Yes.
And you can see pairwise.
Yes.
Pairwise, what is the array? See, brand 3 is standing separate because it is not at all compared. Brand 2 and brand 4 are same.
Okay.
Brand 1 is towards this side.
Yes, sir. Okay. Okay, sir. Thank you.
So let's go for the next topic.
Yes, sir.
Yeah. Now we will discuss about these topics. Just a moment. I'll show you what topic we're discussing. We'll discuss about factor analysis. Now, factor analysis is a dimension reduction we call. I'll show you an example before I go to that. I'll close all this stuff which I have opened. Yeah. I'll show a question here. For example, just here, we have, I forgot where is the question, my questionnaire is. Yeah, before going to factor analysis, so this is the questionnaire which data was collected long back, I think 5, 6 years or 7 years back it is collected, about eco-friendly products. Okay, so the respondent have taken environmental behavior, knowledge about eco-friendly paper and attitude. Totally 10 statements he has made. For our understanding purpose, we have segregated here into different factors. But when we give to respondent, we don't actually do the subheading and heading. We simply keep this 10 as a only one box and we ask them to rate on a Likert scale of 1 to 5. 1 is strongly disagree, 5 is strongly agree. Is it okay? Now, when you want to divide or group these 10 variables into different segments, this is what we call as factor analysis. Can you understand what I'm saying?
Repeat, sir.
Yeah, here in this research work, the scholar want to know the opinion of some respondents about different statements. He has made 10 statements and he has collected the respondents' opinion from strongly disagree to strongly agree. Okay. After 10 statements data is collected, he want to group these statements because 10 statements are there, but he has asked, if you see first 3 statements, actually he is expecting under environmental behavior. Next 4 statements is expecting under knowledge about eco-friendly product. And the third 3 statements are under a factor called as attitude. So he want to check whether they are forming as a components or not. This is what we are going to do in factor analysis. Is it okay?
Okay.
Now, this factor analysis is called as exploratory factor analysis. We call it as EFA. Right? Now, this EFA must be done when you are framing your own statements, because there is no what you call as research on this. Then only you do EFA. For example, you are doing like service quality type of research where already 5 factors are already there, like tangibility, all these things are already there. Then there's no need to do this EFA. Okay. But if you this EFA should be done when you are creating your own statements and to understand how they are getting grouped. Then only you are going to do this factor analysis. Am I clear?
Sir, please repeat it again. Please,
right,
sir.
madam. So in research, we have 2 types of factor analysis. One is exploratory factor analysis. The other one is confirmatory factor analysis. Exploratory and confirmatory. What is the meaning of exploratory? You have created, researcher has created his own statements and want to see how they are forming into components. Means you are exploring the data. Then we are going to do this exploratory factor analysis. If already there is a study which already explored, there is no need to do exploratory research. We do confirmatory factor analysis. Okay.
Sir,
In this case, the scholar has created 10 statements. These statements are his own sentence formation. Under each heading, he has created some statements. And he wants to see whether they are forming into that component or not.
Excuse me, sir.
So, suppose
Yeah.
that if I am conducting a research in which I'm using a scale based in Europe on Indian population. So in that case, I'll be doing EFA and CFA. I find that
this
CFA
scale,
is
it's very
appropriate
clear.
and EFA gives a different result.
It is very clear that if a study which is already done, authenticated study, if it is all scale is already there is no need to explore the data once again.
Okay.
Okay.
I should go
No
with
need.
the
There is
factors
no
as it
need.
is.
For example, we call theory of planned behavior, technological acceptancy models, service quality models. In this way, there are different models are there where the statements are already predefined, and in many research that statements are used. For example, service quality 5 factors we use. Many people may be knowing that. So that 5 factors, again, there is no need to do exploratory factor analysis. Directly you must do CFA only.
Okay.
In CFA, you are going to confirm. In CFA, you are going to confirm whether they are forming group or not.
Okay, sir.
Yes, please.
Okay, sir.
Sir, if I'm using the predefined statement of some other sector,
Okay.
then the EFA will be applied. Suppose I'm using the statement of health sector and I want to check the same statements for the automobile sector. Then the EFA will be applied.
Here statements in the sense, madam, same stanza, same phrase words, everything should be same. Even you change one sentence also, even one variable change also is modified. And you must do EFA.
But if I'm using the same, exactly the same statement.
For example, here, see the scholar has used 10 statements, right? Exactly 10 statements. This is done for echo paper and you're doing for jute bags. It is okay. There's no need of EFA.
Okay.
But if this is a 10 statement, first statement, a sentence is slightly modified, then you must again do the research. EFA should be done.
But sir, like if these statements are applied in the jute bag industry, and if want to check these factors for the automobile sector, see same statements I want to use, then the EFA will be applied or not?
Madam, I am only saying about the particular model. I'm not talking about is the model industry specific or not. I'm not talking. Okay. I'm saying this, the model, if the model, you have, what you did, you have changed the industry, right?
Yes.
You have changed the industry. So there are some models which are industry specific. So I don't know whether the model which you're talking is industry specific or not. If it is industry specific, then you change the industry, then automatically you must do EFA again.
Okay. Thank you, sir.
Yeah, industry specific models, because you must discuss that model in such a way that is it industry specific. It is not industry specific means there's no problem whether you use automobile industry or textile industry.
Okay, sir. Thank you.
Right. See here, actually the concept is when you are making your own statements, you don't know whether they are forming as a component or not. To check this one, we are doing this factor analysis. Any more doubts you have, you can ask at this moment, because directly I'm starting the analysis. Right. Now here, the same questions. I have already shared this data with you in factor analysis, SPSS file. Right. Here you can see there are 10 statements are there. Okay. These are the question numbers which we kept, and these are the statements. And here you can see that values, sorry. One is strongly disagree, 2 disagree, and neutral, agree, and strongly agree. Now I want to do factor analysis to see how they are going to form into group in factor analysis. So I'm starting the procedure of an analysis. Analyze.
Satish sir,
yeah?
Excuse me.
Yeah.
Sir, do we need to change it to scale? आपने ordinal कर रखा है.
Yeah, we need to change it to scale. Yes, you can see.
But in your sheet, it's ordinal. If you can see.
Yeah, it is ordinal. It is ordinal.
So when we use scale 1 to 5, it is called as ordinal.
See, this Likert scale is an ordinal data. This is ordinal data. Likert scale 1 to 5 is an ordinal data. There's no doubt. I don't know who said to you this is a scale data. This is an ordinal data.
Okay, sir. Done.
It is ordinal data. There's no confusion in that, because you can see my YouTube channel. Lot of videos I prepared in order to remove the difference between scale and ordinal data. Now we have 5 statements are there which are Likert scale, and these measurement types are ordinal. Okay. Let us start the analysis. Analyze. Dimension reduction. Okay, factor analysis is called dimension reduction. Means why we call dimension reduction? If there is a statement which is not in the component, then automatically we are going to eliminate that statement. So we are reducing the dimension. So in this dimension reduction, factor analysis. Analyze, dimension reduction, factor. In this factor, select all the 10 statements. Okay, after selecting from left side to right side, required statements are being transferred. Descriptives, click this button called descriptive. Okay, in this descriptive button, only select KMO, Kaiser Meyer Olkin Bartlett test of scarcity. I'm saying the important buttons need to be checked. We can select all this coefficient, significant level, all this can also be selected. But just I want to focus you how they are forming into a group. Continue. And there is no need to go for extraction, because in extraction by default, eigenvalue greater than 1 only will be displayed for us. Eigenvalue greater than 1. Okay. This is by default, it is there. So I'm not doing any sort of extraction here. Okay, continue. In rotation, we must select Verimax rotation. Generally, we select Verimax rotation and with loading points. Okay, continue. Verimax rotation.
Sir, what is Verimax rotation?
Yeah. In method, of doing for this factor analysis, I am using Verimax rotation. Generally, this is what generally we use. We can use Promax. Promax will be getting pattern matrix, structure matrix will be getting, or Equimax also you can select, but generally Verimax rotation we will be using. And in options, there's no need to go for scales. There's nothing in scales. We'll go for options. In options, there's nothing to select here. Just click continue and click OK. So I have selected only two buttons. Descriptive, select KMO value. In rotation, select Verimax with loading points. Only these two settings I did in order to keep the analysis in a very focused way. Click OK. Once I clicked OK, you can see KMO. KMO and Bartley test, this is very important. The grouping now, what we are going to see, is it valid or not valid? Is it correct or not correct? To discuss that one, you must see this Kaiser-Meyer alkene. It must be more than 0.7. Must be more than 0.7. In our case, we got how much? 0.730. So the grouping what I'm going to see now is correct. Is it okay? If it is less than 0.7, the grouping what you are going to see is not correct. Is it okay?
Sir, please repeat it again. This
KMO value, Kaiser-Meyer alkene, this value 0.730, this must be greater than 0.7. If it is less than 7, you please stop your analysis here only, because what the results that you are going to get is not correct. There is no meaning in going further.
Sir, if the value is less than 0.7, can we change it by changing any factors or like that? How we know how to?
See, manipulation or elimination of variables is second part that we must discuss separately.
Okay,
now
sir.
Here we are taking as it is, as the data is there, we are discussing.
Okay, sir. Okay.
Manipulation of data or data elimination, that we must discuss a second part. I'll explain you that later.
Okay, sir. Okay. Thank you.
Just we are seeing, we are reading the data as it is coming out. So this is the first one, important one. And we're not discussing about this commonalities now, because my important, what I want to interest is total variance explained. The total variance explained, if you see this agent, cumulative agent, you must see this one, 79.407. This must be more than 60%. This is a second important constraint. In total variance explained, the commonality must be more than 60%. If it is 70%, excellent. 60% acceptable. So it is in our case, it is excellent. Means how many groups we are getting? See, components, you can see there are 3 components only we are getting. Means still 3 components only system is displaying, because in the setting I said agent value greater than 1 only should be given. So it is displaying till 1 only. If you see the 4th component, the agent value is less than 1. So system is not displaying any data for that. It is displaying for only 3 components. Means totally the 10 statements are grouped into 3 components. And see the commonality, it is more than 70. It is 79.407, which is excellent. Excellent grouping happened. Total variance explained is excellent, which is more than 70%. 60% is acceptable. Less than 60%, the grouping which has formed is not acceptable. We must not go further. Is it okay? So 2 important points I have discussed. And third important point is, don't go with component matrix. Directly, you must go to rotated component matrix. Rotated component matrix. In this rotated component matrix, all the 10 statements are grouped in under 3 components. Now, please read the first statement, statement 1, component 1, component 2, component 3. Where is the highest value here? In second component, right? So variable 1 is grouped under component 2. If you see the second statement, I will carry my own bag while going to supermarket. This is second component because here the agent value is more compared to this. More than 0.5 it should be. And if you see third value, this is also under component 2 only. Means first variable, second variable, third variable are grouped under second component because the other components are very less. Able to understand what I'm saying?
Yes, sir.
Yes, sir.
Yeah. If you see the fourth variable, it is grouping under first component. Why? Because the value is very high here. It is 0.95, whereas for other two components is very less. So fourth, fifth, sixth, seventh, all these four are grouped under first component. They are grouped under first component. Because second component, there is no values. They are very less. Here also very less. These agent values, loadings, we call this as loadings, it must be more than 0.5. And now when you see eighth variable, 9th and 10th variables, 8, 9 and 10, they are grouped under third component. Because 8th variable is 0.658, whereas the other two are very less. 9th 0.827, 10th 0.814. So they are grouped under third component. Means now it is very clear that first three variables are grouped as first component. Fourth, fifth, sixth, seventh are grouped as first component. And 8, 9, 10 as grouped as a third component. So this is how the exploratory factor analysis formed. You can see this diagram also. First, second, third has formed as one group. Okay. Fourth, fifth, sixth, seventh has formed as another group. 8, 9, 10 has formed as a group. So this is how we can come to a conclusion that the exploratory factor analysis, using exploratory factor analysis, we are able to group the components. Here I just said only 3 points. First point is KMO value. This KMO value must be more than 0.7. Okay. Automatically, Bartley test of sparsity will follow. There is no need to worry about this Bartley test of sparsity. You must only bother about KMO value only. Next is about total variance explained. We said more than one eigen value only should be displayed. So automatically, if it is less than 1, it is not displaying. It is displaying only till 3 components. See this total variance explained. It must be more than 60%. Acceptable. 70% is excellent. And it's nearly 80%.
Yeah. Sir, what is the mathematics behind it? Like the first 3 components are coming under first factor, then 4th, 5th, 6th, 7th.
Yeah. I'll show the statement here, sir. Okay. If you give the same statement questionnaire to a respondent without headings, without this environmental behavior, all these headings, automatically he'll read the statement and tick some box, right?
Yes, sir. Yes, sir.
Hello. Yes, sir. When he's ticking, yes, sir, yes, it means yeah, first variable, second variable, third variable are having same type of property.
Okay, sir.
4th, 5th, 6th, 7th is having same type of property. 8th, 9th, 10th is having same property of same type of property. I'll give you a simple example. In a hotel business, you want to know about 3 dimensions of that hotel, about food quality, okay, customer service, yes, and billing. You have asked some 5 questions under food quality, about food related statements. Next 5 you have asked about hospitality. Next 5 you have asked about billing and payment. Okay, so you're not going to make any sort of heading there. Directly you ask some 5 questions on one heading, and 5 questions on other heading, 5 questions on other heading. The respondent, when he goes on ticking, the questions which you have asked on hospitality should come under as hospitality only. The questions which are asking on food quality should form as food quality, and the questions which are asking under billing should form as billing only. Is it correct or wrong?
Correct, sir.
The same thing we are checking. We are asking question, expecting that the question which I asked under billing should come under billing. Now using this EFA, we are trying to see whether they are formed or not. The system is showing yes, they have formed in the same grouping wise. Okay, I'll do this factor analysis in order to make you clear. Dimension reduction factor. In options, you just click this button, suppress small coefficients which are less than 5. Now clearly you can see in the output. I'm suppressing small coefficients, absolute value below 0.5. Now you can see clearly here. Rotate component. First, second, third formed second component. Fourth, fifth, sixth, seventh formed the first component. And 8, 9, 10 form the third component.
This is a standardized value of suppressing less than 0.5.
Because 0.5 above only we are interested. That is called loadings.
Sir, in some paper, I have also seen that more than loadings of 0.7 are taken.
It is coming. Fortunately, we have that values here.
My confusion is whether in our paper, if suppose I am writing a paper on factor analysis, that factor loadings more than 0.7 can be taken or not.
0.5. If you take more than 0.5, means automatically 0.7 is taken, right?
No, all values more than 0.7 are taken.
No, ma'am. That is for KMO table, not for here, not here.
KMO table.
That is for KMO table.
Yeah, this one.
Means for factor loadings.
You're talking about KMO values, or you're talking about rotated components?
No, I'm talking about factor loading.
Factor loading. This one, KMO.
Factor loading, sir.
Rotated component. This one.
Yes.
Okay. She's talking about factor loading. These are called as loadings. Here, fortunately, we are getting more than 0.7. We are getting, but 0.5 will be displayed for all the values.
Okay.
For example, I remove that option and I'll show you. I remove that option because to make you understand, I kept. I'm removed. Now you can see. You can see there is no 0.5 other values. Okay, for these values, it is more than 0.5. More than 0.5 has formed as a group.
Okay, sir. Fine. Thank you, sir.
There is no other value. That's why it's not showing. If, for example, I'll say, for example, there is a variable which is having loading more than 0.5 in more than 2 components, for example, that we call as cross loading. Okay, and you must eliminate that variable from the analysis. If there is a variable which is having more than 0.5 loading in more than 2 components, for example, imagine this question number 5 is having in the first variable, first component and second component also more than 0.5. Then it is called cross loading. Okay, then you must eliminate that.
Okay, sir. Okay.
And in some cases, some variables will not have 0.5 loading in any component. For example, 7th variable, for example, I'm saying this is not having any sort of loading which is more than 0.5. We call no loadings. Then also you eliminate that variable from the analysis.
Okay, sir.
Okay, cross loading, no loading. These 2 cases you remove. Is it okay? So this is what is called as exploratory factor analysis.
Sir, excuse me. Here, second component have factor loading more like 0.957, 0.956.
Correct.
It is greater as compared to other factors. So can we say this factor is stronger than other? Can we say this thing?
That factor comparison we must do in the separate one, not here.
Okay.
You want to compare between the factors? Yes, you can compare between the factors.
We can't say.
Okay. No, not on the basis of these loadings. Can we say? CFA and do that. In CFA, we are going to find the variance, and there we are going to do further research, because all research we don't do in EFA only. EFA is only restricted.
Components we are finding out.
EFA is restricted to know where how the components are forming, where the cross-loading is there, or what is the total variance explained. These things only we are going to discuss here. Further, we are going to do the same study in EFA now.
Okay, sir.
Excuse me, sir.
Right. Now, after EFA, now you confirm that in factor component 1, we have group 1, 2, 3. And in component 2, 4, 5, 6, 7 have formed as a second group component 1. 8, 9, 10 has formed as a other component. Now it is exactly like what is a researcher is expecting. You can see that 1, 2, 3 is expecting as environmental behavior, right? 4, 5, 6, 7 is expecting as environmental friendly, knowledge about eco-friendly products, knowledge. And 8, 9, 10 attitude. So fortunately for the scholar, there is no need to eliminate any variables from the analysis. So you can take as it is and go further analysis. Is it okay?
Sir, excuse me, sir.
Yeah.
Sir, if any component only one or two items.
No, madam. One is not taken, madam. 2 should be taken minimum.
Excuse me, sir.
Yeah, please.
Sir, like as you have said that, like if the loading is coming below 0.5, then it is considered as no loading. But in the case like if you are getting the in the 2 cases like more than 5, then it is considered as cross loading. So which one we have to eliminate, sir, then?
No loading means if a variable is not loading under any component, it means automatically you are going to eliminate that variable.
Yes, sir. Yes, sir.
And second one, I will not get. I cannot get you.
No, sir. Like as you have said that, like for one statement, for 2 components, we are getting the loading more than 0.5.
Cross loading.
In that, yes, sir, cross loading. Then in that case, which one we have to eliminate, sir?
See, there is a variable called, for example, fifth variable, the fifth statement. Yes, you are having loading under first factor and third factor. For example, under environmental behavior also it is loading, under knowledge also it is loading. Then eliminate that statement itself.
Okay. Okay.
Okay.
Okay. Thank you.
Right.
Excuse me, sir. Sir, if
please.
Component is having only 2 items, I mean 2 questions or 1 question greater than 0.5, in such a case, should we consider that statement or not, sir?
100% you can consider. There are 2 statements also we can consider.
Thank you, sir.
Yeah. Now, since now we got EFA, now the next we are going to do is reliability tests.
Sir, 1, 2, 3 items, these are coming under one factor, one component.
Correct.
So their mean and variance will be exact same. What is the basically mathematics?
We'll go further to diagnosing that.
So why are principal components?
Hello?
So please show the principal components.
You want to see the method which we have used. The extraction method is principal component analysis. Rotation method is Verimax with the Kaiser normalization.
No, I'm saying that where are the principal components we are getting out of this exercise?
Principal components we are getting. These are 3 principal components.
Factors, yes. So what
is the factors? First factor, each component is a factor.
Yes, but what are the values of these components for each observations?
Values for each. Sir, for first variable, for the second component is 0.75, 0.89, and this is the values which you got.
So these are the loading.
Yeah.
I'm talking about the. You need to save the principal components as a variable. Then you will get to the principal components for each and every observations.
That's it, sir. Now that's what I'm saying. What you are saying is now the scholar has environmental behavior as one factor. Now these 3 variables take the mean and write as a variable. take the mean of these 4 variables and call it as knowledge knowledge about eco-friendly products. Take the 3 variables and write as an attitude. Okay, because now they're forming as these 3 variables are forming as a component. Now you can take the mean of the 3 variables. Okay. Now let us see the reliability test of this data. Now to do reliability, what is the meaning of reliability? Means how far they are able to say that they are forming a component or not. Let me do analysis in this scales and reliability analysis. Now this is further analysis to EFA. I'm taking 3 because already we confirmed that first, second, third is forming as a component. I'm taking them as an item and simply click, and you can see the model I'm selecting is alpha. Click OK. Now the reliability is Cronbach alpha is 0.930. Now this confirms that the 3 items are having reliability. Okay. If it is less than 0.7, we are not going to consider the variable. I'll just explain you further how to eliminate that variable if it is not in the reliability. Scale, you have taken reliability analysis. Go to statistics and select this button, scale if item deleted. Continue and click OK. Now you can see that with the 3 variables, the Cronbach alpha is 0.930. Now in this, what is the role of each variable means if I delete first variable from the component, my reliability will come to 0.870, means the reliability of the group is decreasing. Is it okay? And in this component, if I delete second variable, the strength of the reliability will increase because it is 0.93 only here with 3 variables. If I delete second variable, the reliability is going to increase. How much the reliability will become now? 0.944. But if I delete the third variable, the reliability will reduce. So this is a way we are going to see within a component how much the role of each variable is. Now 3 variable together, it is 0.930. Minimum it should be more than 0.7. Minimum it must be more than 0.7. But if I delete first variable, the reliability will reduce to 0.87. Second variable, the reliability is increasing, means this is much better. It's always better that I delete the second variable from the analysis now. But I cannot delete third variable. If I delete third variable, my reliability is going to still decrease. So I'll just do the same thing by deleting the second variable from the analysis. Scale, reliability, I'll delete second variable from the analysis. I'm taking only 2 variables, 1 and 3. Click OK. Now you can see Cronbach alpha is 0.944. And if I delete first variable, you don't get any sort of reliability at all. So we must not delete first and second one because already there are only 2 variables are there here, 1 and 2, 1 and 3. So this is how we are going to see the Cronbach alpha reliability test. And in the same way, let us do for the next component also. Analyze, scale, and next component what we have is 4, 5, 6, 7. See, okay, scale if item deleted, click continue and click OK. Now the reliability is 0.919 for 4 variables in the second component. Okay, for the next factor. If you delete fourth variable, it is decreasing. 5th variable, it is decreasing. 6th also decreasing. But understood that 7th, if you delete, what is happening? The reliability is getting stronger. 0.951 it is becoming. So if I delete the 9th variable from the component, not 9th, 7th one. Okay, now see the reliability has still got strong, 0.951. But any other variable, if we're deleting from the component, we are not going to get the same type of strength. Is it okay? And in the same way, if we see for the next factor also, Next factor also, just remove them back. 8, 9, 10. And see this. The reliability now it is very less. See, it is less than 0.7. So the three components in the factor, these three variables are not having required Cronbach alpha. So what is the problem? You must eliminate the 8th variable. If I remove 8th variable, my reliability is going to get stronger. It is 0.79. So again, let me do the analysis for the same. I am removing 8th variable from the analysis. Yes. Now it is 0.79. Now what I understood is from the first factor in 1, 2, 3, second variable must be deleted. In second factor, 7th variable must be deleted. And third factor, 8 must be deleted. If you're not interested, if it's not a problem to even you delete or not second and 7th item variable, but compulsory you must delete 8th variable, because if 8th is added, the reliability is coming to what? 0.685. So this is how we are going to check after EFA is done. This reliability test must be done. Is it okay?
Yes, sir.
Yeah. Now this is all about exploratory factor analysis and reliability test. And after exploratory factor analysis and reliability test, we actually do CFA. So this we are using SPSS Amos software, and this CFA we cannot do using SPSS basic statistics. This is SPSS Amos. So in SPSS Amos, hello.
Sir, excuse me, sir. Sir, can I ask a question, sir?
Yeah, please.
Sir, you are saying that alpha value, if it is greater than 0.7, it has to be no.
Yes.
Is there any meaning in increasing Cronbach value from 0.8 to 0.9 by deleting any questions, sir?
That's what, madam. If in this case, for the third factor, when you make 8, 9, 10 as a group, as a component, you can see that 0.865. If I delete 8th variable, my Cronbach alpha is going to come as 0.709, right? So I am deleting 8th variable from the analysis. This is what you're asking?
Sir, my question is, already my Cronbach value is greater than 0.7, which is, say, for example, 0.83.
Correct.
But I am getting 20 questions into one component.
Okay.
So I want to reduce number of questions. For that, I am deleting somewhat questions and increasing Cronbach value to 0.9.
Okay.
Can I do that, sir?
Yeah, it's up to you. It's up to you. See, if you think that question sacrification is not a problem for you, then you can sacrifice them.
Sir, thank you, sir.
Yeah, if you want to sacrifice, it's up to you. But generally, people think they have some mechanism of asking the questions, right? Because that sometimes that question plays an important role. They don't want to sacrifice. Then it's up to them. For example, if you see this earlier one, already it is 0. Not this one. Just a moment. In this case, if you see, already it is 0.919, right? If I delete 7th one, it is going to become 0.951. So whether I want to delete this one or not depends on my analysis. But there's no compulsion that I must compulsory delete 7th variable, because already my Cronbach alpha is 0.919. Is it okay? Hello?
Sir.
Yes, sir. Thank you, sir. Thank you so much.
Welcome.
Sir, sir, can I ask a question?
One question could be important for you and may not for me.
Sir, I had read in some articles like that if the Cronbach value
I'm not getting your audio, please. I'm not able to hear your audio.
Sir, Sir, is it audible? Sir, I had read somewhere that if the convex value is above 0.9, the data is considered as manipulated like that. Is it authentic?
See, when you genuinely collect the data, sir, why they say it's manipulated?
If the value is above 0.9, like that, they somewhere.
No, sir. See, where is the point of saying manipulation? If we have not did any manipulation, then why are you going to say manipulation?
Okay, sir.
If a student gets 100 out of 100 marks, do you think he's copied?
No, never.
Then
okay,
it is up to our assumption. There's no rule, sir. If the student gets 100 marks, you can say that student has copied because no one can get 100 marks.
Okay, sir. Okay, sure. Thank you.
So we do all this reliability test and all after pilot test of our questionnaire, right?
Madam, pilot study, main study, that is a different way of thinking, madam. That should be discussed later.
Okay.
You'll get confused now because pilot study and main study and how much sample is required. So that's all discussion you must do initially when you start your research. Okay, we are talking about only whether they are forming a component or not component.
Okay, sir.
Right? That need to be discussed in a different title, madam, because you'll unnecessarily get confused when I start discussing those things. Okay, so after EFA, after reliability test, the next stage will be about structure equation model, where you are going to see the structure like this, which I've drawn the structure using SPSS AMOS. Is it okay? So here I have made 1, 2, 3 as factor 1, 4, 5, 6, 7, 8 as factor 2, 8, 9, 10 as factor 3. But now, just now we understood that 8th variable cannot be used because the reliability is not there. No, I'm taking only 9 and 10. Don't get confused because I have not taken up this software how to explain you, but directly I'm just showing you the possibility how you are going to do further research. Okay, after EFA, this is where you are going to come into SPSS AMOS, and here we are going to do CFA because CFA cannot be done in SPSS statistics basics. So this must be in AMOS. And one important thing here we are going to talk about validity of the models. Validity. What is the validity? Means we have two types of validities: convergent validity and discriminant validity. Convergent means how close this 1, 2, 3 variables towards this factor. That's called convergent validity. How close they are. Like for example, factor 2, you are saying 4, 5, 6, 7, 8. How close they are. This is called convergent validity. Discriminant means how far one factor is from the other factor. From factor 1, how far it is from the other factor. This is called discriminant validity. We talk about convergent validity and discriminant validity. So convergent validity will say about how far they are very close together. We talk about a value called as average variance extracted. There is a variable called as average variance extracted. With that, we are going to do about convergent validity. And the discriminant, we are going to see the correlation between these values and how much it is less than the AVE, average variance extracted. So this validity and reliability, you can see my YouTube channel. This is the channel I have. This is my own my channel which I'm keeping my videos here. We need to do this with manual calculation, means not with a software, but manually we have calculated. Composite reliability I have explained here in this case, finding reliability of SCM models. And here we have discussed with 17 minutes video how to test convergent and discriminant validities. Here you can see this here, convergent and discriminant values. If you're interested further, you can go and you can check these videos. And next, what is important, many people ask is about multicollinearity. Multicollinearity between here, for example, what is the multicollinearity between factor 1 to factor 2 to factor 3? As multicollinearity means they must not be collinear, they must be very far away. That also you can check with this particular video. We have written about multicollinearity tests, how to do multicollinearity test. This one we are going to see. Is it okay? Able to understand what I'm saying? Hello?
Yes, sir.
I'm saying extension. We're not going to discuss here, just concept I'm discussing. After exploratory factor analysis, you are going to do reliability test, cronbach alpha. After that, you are going to confirm that with structure equation modeling, CFA. In CFA, you are going to discuss about validity once again. That is convergent validity and discriminant validity. In the initial days when I'm started this analysis of PhD, the scholars used to ask me, sir, my supervisor said to find the reliability and validity of the questionnaire. I used to say, what questionnaire? For the questionnaire, reliability, validity will be there. Actually, it is not that. It is for the scale. Please understand. Reliability and validity is for the scale, for not the questionnaire. Okay? So initial 10 years back when I started doing, then later I explained many people that you don't please say questionnaire reliability and validity. It is a funny thing. We don't have validity and reliability for the questionnaire, for the scale. For each scale you'll be having for this ordinal data, we have a reliability and validity. I've just now shown you the reliability, Cronbach alpha. And validity also you can do with the CFA. You can see my video where I have calculated manually using Excel sheets, not with SPSS software, but we're using Excel. I have calculated. Even I have shown you how to calculate that multi-collinearity test also. So in this videos, you can see so many other things in this test. Okay, this is my channel. Yeah, it is SPS Amos. SPS is Amos, structure equation modeling.
Structured question modeling.
Structure equation modeling, SPS Samos. In playlist, you will be having all this structure equation modelings. These are structure equation modelings. Right? Anything you want to ask at this moment?
Sir, one question.
Yeah,
Sir,
please.
how we can find summated rated scale? Yesterday, when I had asked you,
Summated rating scale means now I have question 1, question 2, question 3. These are called as Likert scale, right?
okay, sir. Yes.
Now let me do summated rating scale, transform, compute variable. Let me call it as factor 1. Okay. Factor 1. Now let me take the mean of 1. I'm taking the mean. Now I got factor 1. Now see, computed factor 1. If you go to the data and you can see this data, this is factor 1. You can call this with a name. What name you want to call? Environmental behavior.
Behavior. Okay. Can you please
tell
sure. Those steps once again? Go to transform.
Yes.
Computer.
Let's go to transform. Click compute.
Okay,
and
sir.
Factor 1. I've taken the mean of question 1, 2, 3 because we have confirmed question 1, 2, 3 are into one component.
Yes, sir.
So I've taken the mean of 1, 2, 3.
Okay.
And I clicked OK.
Okay.
And I clicked OK. Now in my data, I got F1.
Yes, yes.
Now in F1, you will be having, this is summated rating scale.
Okay. Sir.
Now this is like a continuous data now.
Okay, okay.
So I have explained you in my videos. You can see summated ratings. I mean, I've explained what is. You can see what is summated rating scales.
Okay, sir. Okay, okay. Summated rating scale. Okay, sir.
Further, how to do that summated rating scales.
Okay, sir.
Is it okay? Any more doubts you have? You can ask now. If not, we'll conclude.
Sir, sir, I'm having a small doubt. Like, how many statements are required to run a factor analysis? So, like, there is any hard and fast rule that these many number of questions are required?
Factor analysis, madam, generally you will be having every factor must at least have 2 statements.
Okay, okay.
At least you must have 2 statements, and sample size, madam, 4 to 5 times. For example, you have 10 variables, for example.
Okay.
10 factors or 10 variables, 10 factors. Into 4 times it should be.
Okay.
Then in how many factors you have for 10 factors into 4 means 40 variables. 40 example. There's a thumb rule, something in Naresh Malhotra book. There is a book called Naresh K. Malhotra.
Okay, sir.
That clearly he explains the thumb rule, what must be the sample size. But for factor analysis doing, madam, at least you must have 2 factors minimum, because 1 factor is called as mono, or we call as single factor, right?
Oh, yes, sir.
You want to require 2 factors, and each factor at least you must have 2 variables minimum. 1 variable we cannot do.
Okay, sir.
So that's only the rule.
Okay. Okay. Thank you.
Sir, what is this F1? Sorry, I missed. What is this F1
F1, I've
variable?
just given a name, sir. Just I given a name. I must call with a name, right? So I called it a name.
And now why we have used it as a scale in place of ordinal? Because we have clubbed the means.
Yeah, we have taken the mean of the variables.
Okay, then we would put it as a scale.
Correct.
Correct. Thank you.
Yes, because it is a scale data. It is a continuous data, right?
Done, sir. Done. Thank you.
Yeah. Okay, I hope all the questions are answered.
Hello.
Yep. Yep.
This F1 is
I can hear
just
you.
a arithmetic mean, but it is not.
It's only representation.
Principal.
It's only representation. It's only representation.
Sir, if you just go to the analyze and then dimension reduction, can you then one option is the score. If you save as variable, then you will get the principal. Sir, can you go to the principal? Yes. Then
okay.
Yeah, now click on scores. Scores down. Yes. Now click on save as variables.
Okay.
Yes. Now continue. And now click OK. Now go to the variable. Yes. Now we are getting principal components here in the data.
Yes, you got 3 components. Same thing. Regression wise, they have formed, sir. This is a regression you are taking. You are taking regression analysis you have taken. Hello.
Yes. So this is what I was saying, that these are my principal components for each and every observation. We have 3 principal components.
Okay. Okay, regression wise we got this one. Regression wise we got principal components. Regression factor scores there. Right, sir? To the scope of this factor analysis we discussed. Okay. I'm concluding the program here. Thank you all.
Thank you so much, sir.
Yeah, thank you very much. If you want to contact me, as I said, if anyone is interested to contact me, you can contact me at this location.
Shamsunder, sir.
Email ID.
Excuse me, sir. Satish, sir.
Yeah, please.
Sir.
I'm done, madam. I'm done with the presentation. Okay, you carry on.
Good afternoon, one and all. I am Shamsunder, research scholar at MJU in the Department of Management Studies. On behalf of Mahatma Gandhi University, would like to propose a vote of thanks to the resource persons
sir,
who
unmute
have
yourself.
contributed. Hello.
Please unmute, sir. You mute చేసుకోవాలి.
We can hear, sir.
Okay. Okay, right.
On behalf of Mahatma Gandhi University, I would like to propose a vote of thanks to the resource persons who have contributed for the today's session. I first of all like to extend my gratitude to Mr. G and Sathish Kumar, sir, for your deep insights about how to apply various statistical tests for the data analysis with the help of the tools. In parallel with the data analysis, thank you, sir, for giving your clear understanding about factor analysis, reliability test, and also Wilcoxon's find ranks test. I would also extend my gratitude to Ms. Uma Maheshwari, madam, for her eloquent and passionate lecture on the mindful eating. This faculty development program is giving a basic understanding to the participants about how to begin the research journey with the objectives and termination of results and interpretation. I thank Dr. Sri Lakshmi Madam, Director FDP, Dr. Ramesh Kumar, Ramesh Kumar Sir, Coordinator, for giving me the opportunity. Thank you one and all. And the afternoon session will include correlation and regression by Dr. Rahul Tangida Sir. Thank you.
So when it will be starting, sir?
It will be by 2 o'clock. 2 o'clock.
Ramesh sir. Hello. Hello. Sir. Hello.
Hello.
Sir.
Hello.
About sir, tomorrow's exam, sir, how we will get to know the test?
Okay. So, sir is not here, madam. I will update in the chat box.
In the post-lunch session?
Yes, yes.
Okay. Okay. Now we can leave the meeting, sir, right?
Yeah,
2 o'clock is
yeah.
starting. Yeah.
Yes,
Thank
yes, yes. Right.
Excuse me, sir. Sir Satish, sir.
Yeah, madam. Bye, madam.
Sir, it's a very nice explanation, sir. Thank you so much, sir.
Thank you, madam.
I've got only a SPSS statistics, how to get the tables and how to identify significance. That's it only, sir. Now you have explained me very, very clearly, sir. Thank you so much for the session, sir.
Thank you very much, madam.
Satish sir, thank you, sir.
Thank you. I'm leaving now. Okay.
Thank you, sir. Thank you, sir.
Thank you all. Thank you,
you, sir.
everyone. Thank you.